So they say third time's the charm, right? We'll see how that goes. This is the third time. First time I recorded an entire video and accidentally muted it the entire way through. Very sensitive mute button on this headphone. And the second time, got a phone call within a minute of starting. So, well, anyway, this is week, what is it, 64? I want to make sure I get this right. 63, 64. This is week 64. Week 64. Richard Feyman, Six Easy Pieces. This is a book on science. Now, Feynman is a scientist who won a Nobel Prize in the 40s or the 50s, I believe. And this is a 1965 Nobel Prize. So after this, he won the Nobel Prize for his development of quantum field theory. So quantum field theory. But this is, in 61, he was asked to provide some lectures to intro physics students. And so that's what he did. And he is apparently believed by many to have been a very good communicator of science. And he was. He could make complex ideas very simple for people. And that's exactly what he does here. And this is not the entirety of the lectures. This is just the first six easy pieces, like it says. And these were published at first in 1963, apparently, but based on those 61, 63 lectures. So what we have here is we have got one, atoms in motion. That's just basic, basic what atoms are and how they move and things like that. Two, basic physics. This explains some of the basic physics of Newton and what was seen to be the case until the 1920s when quantum mechanics and well, particularly quantum mechanics, but quantum mechanics and relativity upended a lot of physics knowledge. And then three, the relation of physics to other science says you might be aware that that physics is fairly math-based, and chemistry makes use of a lot of physics ideas, and biology makes use of a lot of chemical ideas, which ultimately are ideas that come from physics, etc. And so this is one of those places where a physicist is making a case for physics basically being the main science, and all these other sciences are, built on or just can be collapsed partially into, and etc. And then we get a chapter on the conservation of energy, where he deals with what kinetic energy is, uh, and that also leads him to talk a bit about gravity. But it's not until chapter 5, the theory of gravity, where he talks specifically about gravity, and 6 about quantum behavior. Quantum behavior is the one where he deals with the probabilistic quantum world, where particles behave both as waves and particles, where they can have traits that resemble a quantum, a packet of energy and matter, versus appearing to be a force that is on a manifold, which is what a wave is. If I got my terminology correct. If anybody knows physics, they can correct me, and I'm good with it. And so, honestly, I found that the the fifth and sixth chapters were a little bit tedious, and that's in part because there have been a lot of advances since 1961, 63. And Feynman is talking about things that are cutting edge at the time, but they don't know very much about gravity, and that's pretty clear. We can measure gravity. We know what it is. We know how it works in terms of the attraction of two bodies of matter. The Cavendish experiment and other experiments have demonstrated the validity of gravity and the basic theory of gravity. We can measure it, etc., blah, blah, blah. But we still don't know what it is. And in 61, 63, they definitely didn't know. Currently, they are searching for the graviton, the particle that they think is responsible for gravity. The problem is it's so weak that it is very, very difficult to capture it. So, but that's way beyond what Feynman is talking about. In the ensuing 60 years, physics has accomplished quite a lot, and so these lectures are literally 60 years out of date. So, for instance, quarks. He doesn't really know what quarks are. That terminology has not been invented yet, although some of the math that predicts them has definitely been performed. Plate tectonics, same thing. It's not been named yet, at least he doesn't seem to know of it. But the idea is something that he is familiar with. And they're still not sure why volcanoes and earthquakes happen. And this might be something growing up in this generation you never really realized. Before plate tectonics, they really had no idea why a volcano or a earthquake would happen, because it's not until they understood that the Earth was made of these plates that were slowly moving either together or apart or against each other that they began to realize that it was the friction between these plates that was causing these kinds of eruptions of magma and these shaky ground episodes. So he also, what else is, oh, DNA. He also doesn't seem to understand how DNA works. Now, DNA is made up of, four nucleotides, and those four nucleotides combined into three-letter words or codons, and those codons code for amino acids. Now, they're aware that DNA is information that talks to the cells and tells the cells what to do, but that more detailed explanation of those codons and how those codons work, and I believe the entire transcription process of DNA to RNA to amino acid to enzyme is something that they're still kind of unsure about. So advances were being made at this time. I believe DNA was discovered, the helical nature, the double helix of DNA was discovered about this time. So that's basically what this book's about. And it's fun. It's interesting. It's very interesting to see some of the explanations he gives because they are pretty easy to understand. Like I said, I did not find the fifth and sixth essays to be particularly interesting, but the first four were. And I do want to deal briefly with the elephant in the room about Feynman, which is he was a misogynist womanizer who did things like drew pictures of his female undergraduates naked and bullied women into sex and things of this nature. And this is part of the problem, is because he truly is a great man in science. This is the kind of language we get here in the introduction here. I'll make sure I'm on the right page here of the introduction. Yeah. His autobiographical writings, Feynman's autobiographical writings, contain amusing stories of Feynman outwitting the atom bomb security services during the war, Feynman cracking safes, and Feynman disarming women with outrageously bold behavior. Disarming women with outrageously bold behavior. Okay, that's code for boys will be boys. That's code for misogyny. That's code for, someone who is powerful. And Feynman was powerful in the sense of the man of ideas, the man of important scientific discovery, can get away with being eccentric, whereas it would be jerkish, assholeless behavior of someone else. And that's exactly what we see here. Is that relevant to the book? No, not really. But it's important for you to know who the person is you're reading. So if you decide to read this book, just be aware it plays no role in the book. I don't think there's anything in this book about women or men or sexuality or sex or any of that kind of thing. So you don't have to worry about it being a subtext here. It's not here. But that is the man we're talking about here. Yes, he was a genius, and yes, his genius should be celebrated. But at the same time, his misogynistic, negative behavior needs to be called out and understood. So, anyway, a mixed bag reputation for Feynman, but definitely, if you're interested in understanding some basic physics, this is not a bad book. The first four chapters, anyway. Personally, if it were up to me, I would tell you skip the fifth and sixth chapters. They're not as interesting. Partially, there's a lot of math in them, and it's just not as interesting as the first four. So that's my take. Anyway, have a good day, and Hopefully this one records.